Okay, so the topic, we'll look at domain and range of rational functions. Okay, a rational function is written like this, ax on bx. Now, the numerator, which is ax, and denominator, which is bx, these are polynomials, any kind of polynomial. And the important thing here is that the rational functions are always defined for all values of x, except values that make the denominator equal to 0. Right, so for example, now this is referring to your domain. This is actually referring to your domain, all values of x. The range will depend on the graph, but let's think about domain first. Okay, so here's a simple one. You got fx equals 1 on x. Now that's the simplest graph you'll find. Let's draw that out. So fx equals 1 on x. Okay, so if we were going to graph this, we would need a set of numbers, x and y. And let's make some numbers, like -3, -2, -1, 0, 1, 2, 3. You can copy this somewhere in your tablet somewhere or on paper. So this would be a basic rational function. So these are polynomials because actually, remember, this is actually x0. 1 times x0 is 1. So we normally don't write that. These are both polynomials and that power is 1, like that. So that's probably the simplest polynomial you'll find is 1 on x. Also called reciprocal function. Reciprocal. Like that. That's a simple one. So let's try some numbers. So -3, 1 on -3 is -1/3. -2, 1 on -2 is -1/2. -1 on -1 is -1. 0, 1 on 0 is undefined, isn't it? So the graph is not here at 0. 1 on 1 is 1. 1 on 2 is 1/2. 1 on 3 is 1/3. So you could graph it like this. So we've got 0, 1, 2, 3, -1, -2, -3. And then we put the y value. So -3 is -1/3. Imagine that's 1 here. That's -1. So -3 -1/3. So -3 -1/3 is around there. About there. 1 on, so -2 will be -1/2. Bit further down, about there. I put an X because whenever I make a dot, it comes up silly. So -1 -1 is here. So you've got a graph which is kind of going like this. And it's going to go down like this. Like that. And on this side, we got 0. Well, there's no graph here. There's no graph drawn. There's no red line drawn here anywhere. 1, 1 will be here. 2, 1/2 is here. And 3, 1/3 is there, right? So that's about 1/3 here. So that graph is going this way. Like that. So we can draw that axis a bit further. So this is probably the easiest rational function you'll find. And for example, you probably wonder what's happening here. So if we choose a small number like in here, like 1/10. What if x was 1/10 in here? So then y will be 1 on 1/10, which is 10. So I hope that makes sense. So 1/10 here will have a y value of 10, way up here somewhere. So the graph is going this way. Okay. So that will keep going And it will get close to this black line, but it's not going to touch it because you can't have 1 on 0. So your graph will go like that. Now, important here, which we'll be talking about later, this line here, that's called your vertical asymptote. So the blue line is vertical because it's a vertical line. Asymptote, A-S-Y-M-P-T-O-T-E. Okay, that means that your graph will approach the asymptote but never touch it. So this red line here is never going to touch this blue line, impossible. And you can see also an asymptote here along the y-axis, along the x-axis rather. So again, your red line here is not going to touch this yellow line at all. It will get very close to it though, like that. So that's called a horizontal asymptote. So you can probably copy that somewhere because this is what you'll be learning later as too. So horizontal, A-S-Y-M-P-T-O-T-E. But I don't want to do a lot of graphing today because when you do a topic on reciprocal or these function, we do a lot of graphing then. So if you look at your domain, because we're interested in the domain, aren't we? It's the purple, let's use purple. So you can see your graph is going to go forever here. And remember, domain refers to the x-axis. So you have a graph here, and it will go down, but it's not going to touch 0. And here, your domain will be from 0 to infinity. So your domain is actually here to infinity, and also from here to negative infinity. Whoop, less than 8. Make that infinity, like that. So that means your graph is everywhere except x equals 0. And that's what it says in your definition here. It's defined for all values of x except the numbers which make the denominator 0. So if you put 0 in here, this is undefined. At x equals 0 here. This blue line here, there. So your graph is everywhere except x equals 0. So in this case, we will write the domain like this. Let's see. Well, that's for that example. We should write this. So the domain, we can write as, and you can see this example here, x such that all real x, so all x numbers except x equals 0. So it's all x numbers except here, because your graph does not exist at that blue line, because your graph will come down and approach here, but not touch the blue line. And the same on the right side too, over there. So if we look at this example here, let's do another one. So this is a little bit different, 3 on 2 minus x. So already we can say from the definition, so the domain will be x such that all real x except if x here is 2. In this case, if x equals 2, this denominator will be 0, won't it? 2 minus 2 is 0. So you'll end up with 3 on 0 if I put 2 in here. So that means your domain is all real x except when x is 2. That's what's written down here. When you look at your graph, 3 on 2 minus x, let's write that down. So this is your function here. So we have 2 asymptotes when x equals 2. I got that from here. So I went 2 minus x equals 0. Therefore, x equals 2. That's your vertical asymptote. That's how I got this line here. That's your vertical asymptote here. All right. And in this case, your horizontal asymptote is the axis again along here. You're probably wondering how to do that. So if you choose a few values, so let's look at this graph. What if, in this case, what if x equals 10? Look at that number there. So let's think about how to draw this graph quickly. If x is 10, you'll have 3 on 2 minus 10, 3 on minus 8, which is a small number. It's here, there. What if x was 100? Let's try another value for x. I'm trying to find some points on the graph. That's all I'm doing. So if x is 100, I'll have 3 on 2 minus 100, which is 3 on, what's that, minus 98. Really small. So close to 0, but negative. It's this very small negative number. So your graph is coming up this way. Okay, so at 100, when x is 100, I got a really small negative number. So I'm still below the axis here somewhere. And I can do the same when I get close to the asymptote here. And on the other side, what if x equals minus 10? So you put minus 10 into your function, what do you get? 3 on 2 minus negative 10 is 3 on 12, a quarter. So that is a quarter is about here, there. So that point there is minus 10, a quarter. So it's a small number, but it's above the axis. So I've got another point here. And you can choose a couple of points. You can get this point. This is when x equals 0. You'll get 3 on 2. So y equals 3 on 2 minus 0 is 3 on 2. So this point here is 1.5. There, that's the y-intercept, actually. But don't worry too much about graphing. In most questions, you'll be given the graph. But basically, this definition is what you need to remember here in green. Okay, but we'll do more on graphing later. It will make more sense then. Okay, exercise 5. Do you want to think about this for 5 minutes? Now, the domain, remember, is referring to your x values here. So what you can do, you can make dash line here. So go to this exercise and take a look. Then go across here. And you can go across there. So the domain tells me, is asking me where is the graph in the x-axis. So if we look at this graph, we look at the x-axis, you can see the graph is here, right? There, in this range. This is your domain, okay? But your range is looking at the y values. Where is your graph in the y-axis? So that's going to be from here down to here, down to there. So interval notation, let's go back and look at our notations, which is here. So interval notation, x is a member of, y is a member of. So this is interval notation, this is set notation. So just do interval notation for now. So look at this one. This will help you with the homework sheet too. So we would have domain is referring to x, range is y, or fx if you like, because we could write that as fx too. So your domain x is a member of what? Now look at your blue. So the x values are between -1, because that's your x value, that's your y value, x, y there. So your x values are between -1, but not including. Okay, I'll let you do the range in a minute. -1 until 5, but we include 5 because you have a solid dot like that. So when you have when you not include the n value, you use a curved bracket, and when you include the value like 5, then we have a square bracket like that. So in this one, it would be x. Let's go back and check notation. It's good to know both notations, even if you don't use them in my test or worksheet. I think interval notation is easier. So x such that x is, then we use an inequality sign. So in this case, we'll have x such that, now x here is between -1 and 5. And we include the 5, so we have an equal sign there. All right, can you do y for me? Can you do the range? I'll wait a minute. Okay, so now look at the green. Right, I'll give you a minute, do that. If you're in class, it's probably easier to do this. You can talk to people, but anyway, so have a go. I'll just wait for a minute. If you're using a tablet, it's really easy. Just write, and then if it's not correct, you can rub it out. Answer key in the back, so you can check there. So remember, you're referring to ranges, the y values. So domain refers to x values. Range refers to y values in the y-axis. So this is referring to domain in this direction, and range referring to y. So this is the range there. So I'll give you a minute to do that. If you've done that, look at the next question down below. So those of you who don't have a printer, you're going to have to find a way to do this. But I recommend getting a tablet, and I recommend actually an iPad, because I think a lot of universities are requiring iPads now, and they're quite specific about what they want. So if you do get one, I would recommend an iPad, not the Samsung that I have. Okay, how about range? Anyone? What about paying? What do you got? Y is a member of what? Any answer? Anyone want to talk? I'll buy you an ice cream. All right. So Y is from, now go from the lowest value. So here we're looking at here as 1. So we're going to be from 1, but not including 1 again. And we're going to go up to this value here. And this value is 3. Okay, because that's your Y value here. This is 5, 3. So 1, 3. But now we're still including 3, okay, because we have a solid dot still. Okay, so for your set notation, again, we'll have Y such that Y is between 1 and 3. 1, not including 1, and put y there, actually, not x. Let's erase that. That should be y, because we're in the y-axis. And go up, and we can include 3. So it's pretty much, if you can do the interval, you can do the set. I recommend using interval notation because I see this more commonly than the set notation. But you can see how they're related anyway. You can see that this red one is basically the same as this. And the range here is the same as this one here. Okay, got that? I assume you're all listening. What about B? How about B? So do your domain first. Now this is a reciprocal, isn't it? This is a reciprocal graph. It looks like reciprocal graph because of the shape. We have 2 parts and they're curved and they have asymptotes. So this looks like a reciprocal graph or reciprocal function. I don't have the equation. We could write it down, but we'll do that later. How about your domain then? Your graph is here, right? Up until this line here, but not touching this line. And then we will be near this line, but then going to infinity that way. So it's looking like we're going to infinity in both directions, like that. So how about your domain? X is a member of what? Isn't this all real X, isn't it? All numbers except this vertical asymptote here. So you would write, how did I do it before? This one's easy. I just write all real X. Let's do that one. X such that all real X does not equal 2 because your graph does not exist at this value. So graph does not exist. It's not there at X equals 2. So that's your vertical asymptote. Here, how do we write it here? Let's see, there's a couple of ways to do it. I can't remember what's in the answer key. You could actually do it like it's written here, actually. Or you could write minus infinity. You can check the answer key. I can't remember what I wrote there. X infinity, X cannot equal 2, something like that. You could do that. So all real X except X equals 2. All right, and the range is done similar way. So you can look at that yourself. The range will be to here and also to here. So for the set notation, we could write Y such that, so all real Y now, isn't it? Look at the green. All Y values, we have some graph except here, except at Y equals -1. So all real Y except Y is -1. Y cannot equal -1. Like that. And I guess you can do the same here. Actually, what I'll do, let me fix this. I'll do it another way, which is probably the way it's in the answer key. I'm thinking this is going to be from -infinity to 2, union 2 to infinity. That's probably what's in the answer key. You can check there. So -infinity up until 2, the graph will keep going down, but it won't include this x value here. And then it will start from 2 again and go to positive infinity in this direction. So minus infinity to 2, union from set notation, or, that means or, 2 to infinity. And the range would be from minus infinity to -1. Come up. So I'm coming from this direction down here. Come up until here. You can't go and touch this line here. So minus infinity to -1, union -1 to infinity, positive infinity up here. Hope that makes sense. And I don't include -1, so I use the curve bracket in both cases. All right. How's the time going? We've got 20 minutes. So can you do this one for me? I give you 5 minutes until 12:05. Okay, you try this one yourself. So remember domain. Look at your graph here along the x-axis. What's happening to your graph? Where do you see your graph? Where do you not see it? And the range is along the y-axis there somewhere. The domain. And the green is the range, refers to the range. So for your domain, you can see your graph exists everywhere from minus infinity all the way to infinity. But look here, you see that open circle? So it's all real x except 0. Okay, so we could write that as from minus infinity to 0, union 0 to infinity. That's one way we can write it. Or you can say all real x not equal to 0, I guess. So all real x, but x cannot equal 0. Because at 0, we have an open circle. You see that? Which means at that point, there's no graph. So we'll come to the axis and then jump and then go to the other side. So for the y, you see the graph is only between 2 and the axis. And it doesn't touch 2 and it doesn't touch the axis here. So that would be from 0 to 2. That's this area here. I'll use purple. This area here or there. So between 0 and 2. 0 here and 2 up here. So that's that there. So that means x such at, okay. Oh, I guess you just write it similar to this. So all real x does not equal 0. Okay, because the graph is cut at that point. And this one between 0 and 2. Like that. Something like that will work, okay? So we have 10 minutes left. What else is here? Look at this one. Now, these are your radical functions. So take a look here. We have a reciprocal one here. This is a radical graph. Radical function and a rational function here. This is the harder one. Now remember here, you've got a square root. So whatever is here has to be 0 or more than 0. because you can't take square root of negative, can you? So -2 cannot, -1 cannot, but -0 is okay because that equals 0. Square root 1 is okay. Square root 2 is okay. So this denominator must be greater than or equal to 0. Hope you get that. Because if you're under that square root sign, you'll have a negative number and there'll be no graph at that point. So what we do, we let x squared minus 10 be greater than or equal to 0. This must be true. This cannot be negative. Otherwise, there's no domain. We're trying to find a domain here. Okay. Now, if you were trying to solve this, do you remember how to solve those from quadratic inequalities? So what I could do, I could factorize this. Factorize where you can. You'll get x minus root 10, x plus root 10, greater than or equal to 0. Okay, this is the rule x squared minus, or let's call it a squared minus b squared, which is a minus b, a plus b. I'll explain this now because you'll see some in your worksheet that'll help you when you do your worksheet. So this bit must be 0 or more than 0. So we let it be greater than or equal to 0. And then we need to solve this equation, and this will give us a domain. And I can draw a quick sketch after. So your critical points, remember, well, let's just write this out. X plus root 10, and let that equal to 0. So x must be plus or minus root 10 here. So these are your critical points. And I'll do this by graphing because I think it's a bit quicker. I'm not graphing this yet. I'm just trying to get x. So we've got root 10 and minus root 10. And the graph is where we're looking for the graph, where the graph is above the axis. So we draw a quadratic here. Like that. I'm just drawing this here. And we want to know where is the graph above the axis, greater than 0. So that's going to be here and here. So our solution then to this is x going to be greater than or equal to root 10, or x less than or equal to minus root 10, which is which one? B, that one there. That's a bit tricky, isn't it? Because you've got to solve a quadratic inequality. So refer back how to do this bit here if you get stuck. This part here. So you may need to review how to solve these inequalities. So go back and review that. Solving the quadratic inequalities. That's all I've done here. And you can do it by the test point method too, which we learned previously in quadratics. Okay, this one should be easy because it's a rational function. We know that these are defined for all x except when the denominator is 0, except for x values that make the denominator 0. All right, so all real numbers, that's written in every one, isn't it? See? All real numbers, except when this denominator is 0. So when x plus 6 equals 0. If this equals 0, then we will have no graph there. So x is -6, except this one here. So when x is -6, we have no graph. And I'm not going to bother graphing that, but this is your definition here for rational. So all real x, except when x values, any x value that makes your denominator 0. So we got a few minutes. So that's D for the answer, that one. So all real x, except when x is -6. And that's your definition of domain. Should write that there. Not range. This is for your domain definition. So how about the next one? All right. So there should be arrows on here. So look at question 4. You've got a graph. Doesn't matter what the equation is. We've got a graph. It looks like a quartic, some kind of quartic graph. These arrows will go forever. So which of the following could be the range of f? Can anyone tell me? Look at your numbers. We also need to number. 1, 2, 3, 4. -1, -2. 1, 2, 3, 4. So which one is your range? Anyone? A, B, C, D. Sunita, do you know? Which could be the range? Remember, range refers to y values. So where do you see your graph in the y-axis? It's down here, isn't it? Coming up. What's the highest point of the graph? 2. There, we don't go by that point, do we? Not the bottom one, we go to the highest point of the graph here. And this is the line y equals 2, by the way. So your graph is from -infinity all the way up until 2. We can equal 2 as well. Let's put a dot there. So that would have to be the first one, y such that y is less than or equal to 2, down this way. So that one would be A. -2 and 3 are only 2 points, so that doesn't make sense. -2 to 3 would be here, this one. Wait, that's not right. This is not the range at all, is it? And 1 to 2 would be there, this area. Well, that's wrong as well. So these two, we know these two are going to be wrong. Cut them out, you can't see it now. So A for 4. Okay, so hope you're getting it now. This one's harder because this is a quadratic. So what I'll let you do to think about that, think about the graph. I think you need to graph this. And it's defined for -1 to 2. So that means your graph, I'm only interested in this area here. This is your domain. So I'll let you do that one yourself. This is your domain. I want to know what is the range. So if you put -1 in here, you'll get 1 plus 2 times -1 squared. -2 plus 1 is -1 squared is 1. So you'll get 1 here. So f -1 is 1. Then you'll need to get a graph. You'll get some graph here. And then you can get your range. And it will be one of these here. So you can do that one yourself. But it's a quadratic. Now, piecewise, you haven't seen. I'll explain this. And we got a few minutes left. I'm not sure if one of these is in your worksheet here, piecewise. What it means is that your function has two parts. It's got this part and this part, depending on the domain here. So if you're going to graph that, which I recommend. Now, the interesting part is 3, when x is greater than 3. So we've got 1, 2, 3, 4, 5, 0, minus 1, minus 2. So the graph is x squared when x is greater than 3. I'm going to put 3 in for the time being because these are continuous numbers. So put 3 in, you'll get 9. I'll make an open circle, 9. If you put 4 in, you'll get 16. So your graph is going up this way. It's part of a quadratic. That's this side here. That's this one. But this is a linear graph. So if you put 3 in here, you'll get 9 here. So let's color that in. Like that. If you put 2 in, you're going to get minus 4 on 3 plus 11. And then you can calculate that. You're going to get a straight line, which will be going down. So you'll get a line here down to this value. That's this line here. The only way to get the line is to put points in and check. So try some of these numbers and you'll get a straight line here. And it wants the range. So we'll stop now because the time's running out. The range, what is the range? Your graph is up here, going up. So your graph is going up in both directions. This is your quadratic, your parabola, and this is a straight line. But it's going this way. So your range is going to be from 9 up here. So that would be this one here. Y is greater than or equal to 9. So your graph exists up here to infinity, going this way or going this way. So 9 is the lowest point. There's no graph down here, is there? Okay, so that's why we get y greater than or equal to 9. You can try some of these yourself, but you really got to get on the worksheet now, because the next period, when we do function, we'll go to composite function. No, not much graphing here, mainly just algebra.